First up, let's talk innovation. Each year, GRDC funds around 1,000 R&D projects. These are the core medium to long-term projects grain growers have identified as essential. However, as part of its campaign to also deliver short-term solutions to key issues, GRDC has launched the Innovation Investment Awards.
Proof of concept is what projects such as SARDI's newly funded research are called. It's one of 5 projects to be given a grant under GRDC's new Innovation Investment Awards program. In this case, the concept is to develop a quick and accurate method of identifying fungal pathogens.
The methods that we have already to detect them are a bit slow sometimes and quite technically advanced. So either you have to be a morphologist that knows a lot about fungi and can look at the morphology of the fungi. Often that doesn't work though. The other main method is that you would do a DNA analysis and then come up with a test based on DNA, which again has some shortcomings, although is useful.
And this is what's different about SARDI's proposed new identification method, a special detector molecule known as an aptamer. Medical researchers have investigated the use of aptamers as diagnostic tools for a couple of decades, but there are no recorded cases of the technology being used to identify plant fungal pathogens. But first the SARDI team will have to find the right aptamer, and to do that they'll expose a known fungal pathogen to a batch of automatically generated candidate molecules and select those that can be further developed as specific fungal detectors.
Yeah, really all you have to do is keep exposing them to the target, pulling out the ones that work, changing them, exposing them again, really until you get down to a couple of options that are very strong and specific binders to the spores, and that will be your detector.
The implications for biosecurity are big. In many cases, the production of aptamers that can be used to quickly identify known fungal pathogens from the unknown would facilitate more efficient disease management decisions, or in some cases allow new outbreaks to be eradicated. Dr. Kelly Hill, who conceived the project, will be doing the hands-on work to test the concept.
At the moment we don't know if there's enough differences on the coating of the spores to produce aptamers that are very specific to that spore, and that's important if we want to know exactly what species is in your crop or in your grain, and if it's pathogenic or if it's just okay to be there.
By the end of this year, the answer will be known, along with the findings of 4 other proof of concept projects, which received funding in round 1 of GRDC's Innovation Investment Program. Along with SARDI Entomology, the other winners are Dr. Mandeep Kaur from the University of Tasmania, who's developing parameters for a cost-effective instrument to evaluate weather-damaged grain in a simple, rapid and non-destructive way. It'd have widespread application, from testing for pre-harvest sprouting in cereals through to monitoring the quality of weather-affected grain at receival points where high-throughput screening tests are required. Dr. Ian Searle, now based at the University of Adelaide, aims to aid the breeding of canola varieties with improved blackleg resistance. While at Canberra's ANU, Dr. Searle, together with Dr. Alan Lowe, developed the EasyCross platform technology to produce hybrid seed in greater quantities and more cost-effectively than previous techniques. This project will verify the potential for the EasyCross technology to introduce blackleg resistance from canola's wild relatives into breeding programs. Dr. Derek Russell, University of Melbourne, is developing a new slug and snail bait technology for use in commercial crops, where these molluscs have become increasingly difficult and costly to control. By proving this concept, the highly pest-specific and environmentally safe control method will have an improved prospect of being commercially produced. And Queensland's Dr. Michael Stewart from the University of the Sunshine Coast is also working on snail and slug control. The university's molecular research team, led by Dr. Stewart, has identified a variety of neurohormones that are unique to snails. The regulators of these hormones, released by the brain, would make ideal targets for new molluscicides, and the research team aims to produce proof of that concept. It's the kind of opportunity the Innovation Investment Awards have given all of these research scientists. GRDC is investing $1.5 million annually over the next 3 years in this program, and applications for the next round of awards can be lodged in August. GRDC has also been encouraging grain growers to show their innovation, and in conjunction with the Australian Year of the Farmer, ran a Grains Inventor competition. Esperance farmer Mick Fells won the competition with his concept for a crop yield forecast app. With an engineering background and a passion for digital technology, Mick has already developed a computer model and will now use the $15,000 support package won from GRDC to develop the actual app. The concept has proven its worth to Mick himself by saving $150,000 in reduced fertiliser costs over the last few seasons.
Just the last few dry years we've been able to cut back a lot on our inputs and actually make good profits in those years when other guys have been losing money because we just haven't spent too much. So that's what prompted me to actually turn it into an app, is I can actually see a lot of other people, the industry generally, could gain a lot by knowing that holy grail of information, which is what's my crop going to yield as early as, you know, when the seed is being parked back in the shed again.
The farmer inventor already has another app to his credit, one that's improved his spray operation. And this latest innovation has been designed to be an affordable application for mobile devices that will simply require a farmer's previous production and seasonal data to reliably predict yield.
There's no infield measurements or soil tests and all these sorts of things, because the way that we've structured it, it is actually pre-calibrated to the individual putting their data in. So it doesn't matter whether you're in heavy soil or sandy soil or high rainfall or you get dry finishes or whatever, because it models you and your performance as it has been in your environments.
Even though Mick Fells has spent years tweaking his yield forecasting model, he says there are some factors, such as a frost, that can't be factored into the app. But what it does do, it does accurately.
The farmers by nature have to be to some degree a gambler and to a high degree an optimist. And the idea of this app, you're still taking a punt when you put your crop in, nothing's going to change that, but it's just about trying to stack the odds in your favour. I really do believe that having this information is going to create a step increment in the productivity of the industry once people know how to use it to their best advantage.